Hello everyone. Today we are going to discuss about page replacement algorithms one by one. The first algorithm that we use for replacement of pages is first in first out page replacement algorithm, that is FIFO. Then we will discuss about optimal page replacement. Then we will discuss about least recently used page replacement algorithms. Then least recently used approximation page replacement algorithms, which is further categorized in three sub-algorithms. We will discuss one by one. And then last one is counting based page replacement algorithms. So let's proceed. First one is FIFO page replacement algorithm. This algorithm treats page frames allocated to a process as a circular buffer. That means, as the name suggests, FIFO, first in first out. That means whatever the page will enter in the memory at first will be removed first from the memory to the second storage when the page replacement is required in the system during execution. So this algorithm is very simple and straightforward, which tells about the replacement of the page which is staying longer in the main memory, which has stayed for longest time period, that will be removed from the physical memory and will be replaced by the page that is required in the main memory by the process currently under execution. So this, as you can see, the mechanism is very simple and straightforward, so it is easy to understand algorithm. But as it is using the general convention of first come first serve basis, so the by the perspective of performance, it is not a good approach to follow for replacement of pages. And there another problem arises, that is Baladi's anomaly. Baladi's anomaly states that the page which has not stayed for longest can be removed from this, or the page that will be required in the near future can be removed by this algorithm. And that is the Baladi's anomaly, that in the near future the page required for execution by the process, but that page gets removed because it has arrived in the memory earlier than other pages, so it will be removed, which is required later by the process. So this is Baladi's anomaly that arises in the FIFO page replacement algorithm. Other drawbacks: a page which is being accessed quite often may also get replaced because it arrived earlier than those present. That means what it tells is the page जिसको हम बार बार, हम means system, the system जिसको बार बार वो पेज चाहिए फॉर एग्जीक्यूशन ऑफ ए प्रोसेस, वो पेज भी क्या हो जाता है, उसको हम रिप्लेस कर देते हैं विद द अदर पेज फ्रॉम द सेकेंडरी स्टोरेज. So this is the drawback of the memory, physical memory, due to first in first out algorithm. Another one is it ignores the locality of reference. That means a page which was referenced last may also get replaced, although there is a high probability that the same page may be needed again. What it says, the page जो अभी currently use हुआ था in past by a particular process, उस पेज को भी देयर इज चांसेस कि ये प्रोसेस क्या कर देगी, उसको रिमूव कर देगी फ्रॉम मेन मेमोरी, बट दैट पेज कैन बी रिक्वायर्ड इन द नियर फ्यूचर बाय द प्रोसेस अंडर एग्जीक्यूशन बिकॉज द प्रोसेस having that page is currently in execution mode and the page can again be required. But the FIFO algorithm will not think about anything, it will simply replace the page according to the first in first out mechanism or policy. This is an example. Here we have given a string of pages, and we have to load those pages in the memory. The string is 7012030321201701. So this string is required to be loaded into the physical memory with a frame size of 3, 1, 2 and 3 frame size. So we'll start from the first, as the algorithm says first in first out. So we will start putting the pages in the frames. So first we'll choose 7 and we'll put in the empty frame in the physical memory. Then 0 comes and 0 page will be loaded in the next free frame. Then 1 comes and it will be loaded into the next free frame. Now all the 3 frames have been occupied. Now we have to do the page replacement as per the given string of the pages that are required to be replaced or that are needed by the process for execution. So next comes the page number 2. First we will check into the frame set if the required page already exists in the frame set or not. As you can see, page 2 is not available in the frame set. So we will have to find a victim frame, the frame that need to be replaced by the required page. And as the FIFO algorithm says, the page that comes first goes out first. So in this scenario, the page number 7 came first in the frame set. So we will replace page number 7 with page number 2. And the frame set will be having page number 2, 0 and page number 1. Then comes 0. We will check 0 is already available in the frame set, so we will not replace the page as it is already available in physical memory. Then page number 3 is required. We will check that 3 number page is not available in the frame set, so we will need to do replacement. Then we will check which page from page number 2, 0 and 1 in the frame set came first, and we will find that page number 0 arrived first, so it will be replaced by the page number 3. Then comes 0. As we have removed the page 0 from the frame set, so we have to again load the page 0 at the position of page 1 because it is the first page that arrived in the current situation. Then comes page 4 and it will be replaced with page frame having the page 2. Then comes 2, it will replace the page 3. Then comes 3, it will replace the page 0 according to the same scenario. Then comes 0, it will again replace the 4. That means it is a sequential process. One by one pages will be replaced when if they are not available in the physical memory. Then comes 3, it is already available, so no replacement. Then comes 2, it is also already available, so no replacement. Then comes 1, it will be replaced with page number 2 as it was the page that arrived earlier in the memory. Then comes page number 2 and it will replace page number 3. Then comes 0 which is already available. Then comes 1 which is also available in the frame set. Then comes page number 7. Then this page number 7 will replace the page number 0 as page number 0 arrived at the earlier stage than page number 1 and 2. So then comes then comes page 0. This will replace page number 1, and then comes page number 1, it will replace page number 2, and the final frame set will be having page number 7, 0 and 1. So finally we will have to calculate the total number of page replacements. The number of page replacements will be counted from start. So here the total number of page replacements are, as you can see in the first 3 frames, and then these we will calculate these total number of page faults from the example. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the total number of page faults are 15 in the first in first out algorithm of page replacement. So that is a very huge number of replacements. That's why according to the performance perspective, the algorithm is very less use active, and we try to use some better algorithms that we will be discussing uh, in the next video. Thank you.